Hey, Brianna, how's it going?
Hi.
Hey, everybody.
Hi.
Okay, let's see. We'll give just maybe one more minute and see if everybody else is going to roll in here. We're missing Cameron, Zanetta, Luciana, and I think that's it. Just want to wait a little bit because I am doing a workshop today on classes, and I want to make sure that they're hopefully here. I'm recording it, of course, but be nice just to have them here in case they have any questions. They can just ask right while we're going through stuff. Hey, speak of the devil. Hey, Zanetta. All right. So I guess as soon as it hits 12:05, I'm going to go ahead and drop into what we're looking at for today. And there's 12:05. Okay. So what we're going to be talking about today is classes. Classes are something that you guys you're kind of familiar with. They're types. They're types of things that a user can make. So right now, types that you guys are familiar with are variable types, like integers, floats, booleans. Even if we wanted to talk about some other types you guys have seen that are real helpful, like lists are types, dictionaries, those are types. They're objects, we call them objects. They're objects that have certain functionality that we're going to use over and over again. And Python and a lot of other programming languages, they will allow you to make new objects because they know, we can't have the same model for everything. We can't use lists to describe everything. If I wanted to use a list to describe a shopping cart, well, I could probably describe what's in the shopping cart. I might even be able to list out the parts of the shopping cart, but altogether, the shopping cart needs its own object. It needs its own class, and that shopping cart would have certain things that it can do. It probably has wheels, so it's going to roll around. Has a big basket area. We could talk about how big the basket is, because you guys have probably been to the store where you've seen. If you've been to Costco, they have those giant ones. Like they may have those at Sam's too. They're just massive, big old baskets. Whereas the ones you get at HEB, you got a couple options. You got the traditional ones that are, kind of a normal size, and then you have those ones that are like double decker and they're small and they're kind of compressed together. So if we're going to describe a shopping cart, we need more things to work with. So that's where classes come in, and we can start building some of our own stuff so we can decide how we want things to look and model things how they might be in the real world. So with that in mind, let me go through our assignment that I just added on. I'll go through the workshop on classes, and then after that I can take any questions you guys have about converters, okay, about the converter assignment. So let me share my screen with y'all. Excuse me. Oh my goodness. Sorry about that. Alrighty. So not a lot on here today, just saying we're going to go over a converter assignment, and let's take a look at classes. So this may not make a lot of sense to you until I go over the classes stuff, though. I thought maybe, well, I just wanted to do it to frame your idea around what we're going to be doing with classes with the assignment. So let's just go ahead and we'll go through it, and then some of this may make sense and you'll have a better idea of how you want to frame questions you might have. So what we're going to be doing is we're going to be working with classes, inheritance, constructors. Okay, so if you were taking notes, I would write those things down: classes, inheritance, and constructors. Okay, so what classes are going to do for us, just like I said, is allow us to model more real world things. Okay, not everything that's already built into Python is going to help us do that because they expect us to do it. So that's not a big deal. All right, so what we're going to do is we're going to make an overall class, a class that basically can encompass everything else. And then we'll have little children classes, little child classes. So you have a parent class, you have a child class, and the parent class has all the functionality and attributes that all the children classes will have, but the child classes can have their own special functionalities. So we'll kind of talk a little bit about that. So let's say we wanted to do classes where we're going to be modeling animals at the zoo. Okay, so if we were looking at animals at the zoo, we probably can start breaking them down by some criteria we already know. So one thing is we have mammals. We have a lot of mammals at the zoo. We may also have reptiles. So we'll probably have two different classes right there. We'll have a reptile class and we'll have a mammal class. There are certain things for mammals that are going to be true for all mammals. So what we can say about mammals is they're probably going to have at least 4 limbs, at least 4 limbs. Not all reptiles have limbs, right? Because you might have a snake, right? So we can already start to make a differentiation between the two, okay? So mammals all have fur, they all have hair, so we can put that in. We can put that into our description of a mammal. Um, they feed their young, they raise their young, they actually like take care of them. Some reptiles don't do that. So we're already starting to see why we need to have two different classes for mammals and for reptiles. Now, from there, we have a lot of different types of mammals. We're going to stick with mammals, okay? So if I said, okay, we have a child class of mammals called monkeys, okay? Now, monkeys, we're not talking about chimpanzees and apes and stuff like that. We're talking about monkeys. They have tails. They have 4 limbs. They have fur. They have all the parts of the mammal class that we were talking about. They have all those aspects of a mammal class. But then what's some different things about monkeys that you don't see in, say, a tiger? What's some things that are different between mammals and a tiger? Something we're going to have to say, well, tigers have 4 limbs. Tigers and monkeys, they both have fangs, they have teeth. You know, that's going to be true. What are some things that are different between a monkey and a tiger? Let's see. Let's just start calling on people. Zanetta, what's different? What's different between a monkey and a tiger?
The difference between a monkey and a tiger?
Yeah, give me one of those differences. We talked about a lot of the similarities based on a mammal, them both being mammals. What's a difference that we would see between the two?
Well, a tiger would have more of this orange color compared to a monkey.
Okay, so I think that's something we could probably have inside the mammal class as just coat or fur color. So that might not be completely different. Is there anything else you can think of?
Um, I think tigers have stripes and monkeys don't.
Yeah, depending on the monkey, they may not have stripes, but that could go back to fur color. That could be something underneath fur color that we have a difference in. So fur pattern might be something we would have a difference in. Let's see, somebody popped into the chat. Tigers are predators and generally monkeys are not. Well, generally they're not. Yeah, usually monkeys are eating fruit and things like that. I have seen some chimpanzees hunt monkeys, and they definitely eat those. So if we're talking about certain ones, we could say these particular mammals are herbivores, and these other mammals, these tigers or these chimpanzees, tigers are predatory, so they definitely are going to be eating, other prey. But if you're looking at a chimpanzee, they eat everything. They're just like us; they're omnivorous. So that could be a possible defining thing that we would have separate on a child class.
Opposable thumbs.
Opposable thumbs would be a really good one. Yeah. Prehensile tail. That would be one for a monkey as opposed to a tiger. They have a tail, but they can't grab anything with it, right? Some other things that I was thinking is monkeys will they'll stay and work in groups. Tigers don't like to be in groups. They don't like to be in groups at all. Tigers can climb trees. They can definitely climb trees. They can even sleep up in them. They can, you'll find tigers in trees, and you find monkeys in trees. But they definitely get into it a little bit different way. Monkeys don't have big, giant, retractable claws to help them climb, whereas tigers do. Um, we can probably go into some other little minutia about them, but I think maybe I'm going to give you some different examples of how that parent class and that child class work, so you guys understand a little bit better what we're looking at here. So with the idea of the mammals to monkeys and tigers and all these other animals that are at the zoo, if we look back at our road vehicle assignment, what we're going to be doing, our road vehicle is our parent class. Okay, that's going to be something that has basic elements of it that are going to filter down to all the child classes. And if we think about this, a road vehicle, I'm not just talking about any vehicle at all. So, I mean, this could be, if I just said vehicle, it could be a boat, could be a plane, could be a hot air balloon. But we're talking about road vehicles. So we know that there's going to be a few things that are going to be consistent across all of them. What are some things that are consistent across all road vehicles, Camilla? What are some things that they're just absolutely, you're going to have for a road vehicle?
Wheels.
Wheels, yeah, you're going to have wheels. What's the minimum amount of wheels you have to have?
I'm gonna 2, right?
Yeah, I mean, you could say unicycle, but truthfully, how many
Yeah.
seen out on a unicycle just like, plowing down any busy street? It's probably going to be 2. So we're going to have at least 2. Let's see, Will, what's some other stuff that we need to consider when we're looking at this idea of a road vehicle? We have wheels. What else might we want to take a look at?
Some sort of system of moving those wheels.
Okay, so some kind of power or something like
So a motor or
a motor, yeah, some sort of system of power, yeah, gotcha. Um, then the power for that would be like, let's say you're on a bicycle. What's our power?
human power, your feet.
Right, right. And Daisy, if we're on a motorcycle, which is very similar to a bicycle, what's our power on that one?
The motor.
The motor, yeah. So we have a combustion engine on there. That's going to be our power. So we do have power in both places. It's just that the power is coming from different things. So we could still talk about, I guess we could just use power. We could use that. Let's see here. What are we using here? On this one, we have number of wheels. We have power. We have color. Usually there's some color. I mean, they're physical objects, so they're going to have something. Speed, we're really talking about more like a top speed. If we're talking about a car, what would you say top speed would be? Let's see here. Brianna, what would be a top speed for a car? I still got you there, Brianna? No, Brianna? There's no Brianna? Okay. So just throwing this out there, Brianna, but we got to have you talk during the class or I'm going to have a hard time counting you here. Okay.
Sorry, what? Oh my god. Sorry, what?
So with speed, what would be the difference between a car and a bicycle as far as top speed?
Are in a bicycle?
Yeah, car and a bicycle. What would be the?
Oh, car and a bicycle.
Yeah.
Obviously a car's gonna be faster.
Right. Okay.
Okay.
So, Yeah, car's going to be faster. So top speed might be around 120, or top speed bicycle. I mean, I got a speeding ticket on a college campus doing 30 on a bike. So we could probably say the
What the heck?
end for a bicycle might be 40 miles an hour if you got a good tailwind and you're going downhill and you're really pumping hard. But
Most.
you're not going to reach the top speed of a car. So that's something where we could say, this is probably as fast as this thing's going to go. Okay. Now let's throw a wrench in this whole thing. Skateboard. That's a road vehicle. In fact, you got some e-boards now that'll go pretty quick. So let's run down our list of criteria here. We have number of wheels. How many wheels we got on an electric skateboard, Camilla?
4.
You might also have just one, because there's a one wheel out there. It's just this giant wheel, and
Oh yeah, I've seen that.
yeah, there's a possibility of that. Power. What's power on that one, Brianna? Do you know what power is on the electric skateboard?
Did you say my name?
Yep.
Okay, because you glitched and then I heard brown and then I was like, oh, and then I was like, wait, what?
What kind of power do you have on the electric skateboard?
Oh, I don't know, but I'm assuming since it's electric, it go, let's say like up to like 100 something.
Goes up to 100 something. Well, I mean, we're not talking about speed. We're talking about power, but the electricity
Oh,
is the power on the electric skateboard. Tried to leave a little hint out there for you. Color could be anything. Speed, they'll get up to 20 miles an hour, even faster now with some of them. And then seats, that's the main thing. What about the seats? What about the seats on that one?
On a skateboard?
Yeah, how many seats do you have on a skateboard?
0,
No.
unless you're sitting down on it, and then 1, probably.
Right. Well, since we're talking about a traditional skateboard here, we have 0. So we're going to say that there is just that we need to have that there because it's a road vehicle, but technically we don't have anything that we're working with there. All right, so we can use pretty much everything for our class that we're building here for road vehicle. Some things to keep in mind as we're going through this, as we go through more of a workshop with our classes here. Power can be combustion, electric, or human. That's pretty much going to be the case for all of them. I don't think anything is running off of a sail, although you could have a sail on a skateboard. I've seen it before. Colors, anything school appropriate, because you can get into those crayon colors that are saying like, oh, this is Hulk green or, blood purple, and then that's fine. But then they get into some crazy colors after that. Speed can be any float number. Why would we want to use a float for speed? Let's see. Zanetta, why would we want to use a float for our speed here?
Why would we want to use a float for the speed?
Mm-hmm. And if you give up, you can call on somebody else.
Yeah, I don't really know.
Not sure?
Yeah, I'm not sure.
Who do you want to call
on? Camilla.
Okay, Camilla, why would we want to use a float for the speed?
Because it's a number, and that's how, so, because it doesn't accept, if it's a string, it won't accept numbers.
True. And I guess we could use an integer for our speed. So I guess that's more what I was wondering, like, why would we want to use a float over an integer for assessing speed?
Maybe because, wait, I'm mixing them up, but I'm pretty sure with float you can use decimals, right?
That's right. Mm-hmm.
So you could be more exact.
Pretty much, yeah. Yeah, just so you can be more exact. That's really what it is. Okay, cool. Let's see. So we've got speed, seats. We've got that one, 1 to 4. Although when we throw in skateboard, like I said, that one that might have a 0. And then we're going to talk a little bit about how we can break these up into smaller pieces. So let me pull you guys into PyCharm real quick, and I'm going to run through a few things. And then I think a lot of this will make even more sense. So go ahead and pull PyCharm up here in a second. There we go. So if we're talking about other things we might want to make a class for, okay, you'll find a lot of times when you're working in coding, classes are going to be everywhere. They're going to be all over the place. I actually don't know of too many coding languages that don't use classes. So that's going to be something that we really need to spend a little bit of time on, and we're also going to go back and pull classes and functions together, as well as working with packages and things like that very soon. So let me, I'm just going to make a new project here. Let's see, this one, classes, and make a new one here. Right. And it's taking its sweet time. So let me go ahead and stop this share. I'll put up a new one. All right. You can see this thing loading. Okay, almost there. All right, good deal. So first thing we're going to do, I want to show you guys how to make a class. Okay, so it's pretty easy to make a class. We're actually going to write in class. Okay, and let's use our zoo analogy that we used from before. And what we're going to do, let me turn this thing on so people stop bothering me. There we go. Class. Now, when you make a class, you start off with class, and then we're going to do mammal. Okay, and then the thing about classes is, when we work on Python files in other places, we will use all lowercase, and then we might do an underscore and then another word or something like that. That's just going to be for Python files. Now, when we do a class needs to have the word capitalized, like right what we have here. So if we said mammal animals, this wouldn't be right. We actually want to take that underscore out, and you want to keep everything together. Okay, and then it also has a colon at the end of it. Just like when we're working with condition statements, or we're working with making a function or something like that, we put a colon at the end of it. So in this case, we don't really need a long name. We're just going to do mammal. Okay, and then below that, what we're going to do is we're going to add in some elements that we know every mammal is going to need. Okay, so this is where we're going to be building a constructor. Okay, a constructor is something that is whenever some code is run and you're making a new object, a new instance of a class, it'll go out and it'll grab all this information from this parent class and say, oh, okay, we need all this info, no matter what. So that's where we're going to construct those elements, okay? So if we're doing that, and I'm going to try and go over this a couple times so you guys kind of have a good idea of what's going on. When we do that, what we have to do is right below that, we're going to start defining elements of that constructor for this class, okay? So just like a function, we're going to start off with def, we're going to define it, and then we're going to initialize it. Okay? The way we do that is we do double underscore init self right there, okay? And you'll notice it goes purple on ours. On Python, I'm not sure it makes that color change, although I think you can make that color change if you want it to. Then what we're going to do is right down below it, we can start talking about the things that mammals are going to have. So we have our self right here. Let's start thinking. So we're going to put them inside the parentheses, but then we also place them underneath. So let me show you how that works. So we have self. Let's say fur is one of them that we're going to have. Let's see, what are some other things mammals, all mammals will have? Not all mammals are going to have a tail, so we probably don't want to do that. I guess we could say limbs. So they should all have 4 limbs, whether they walk on 2 or 4, they should all have 4 limbs. What's some other things? What are some other elements of mammals that would carry out through all mammals? Okay, got somebody in the chat there. Let's see. They don't lay eggs. That's true. So we could say live birth, maybe. I'm not exactly sure how we'd use that, but let's just put it in there because that's an element of mammals. Let's do live_birth. They feed their young from themselves, so we could say milk. You can't get iguana milk, no matter how hard you try. So it's just not going to work. Snake milk, right out of the question. Fur, limbs, live birth, milk. What's something else that we might need to add in there? And as I said, this is just an example, so we could stop there if we wanted to. So from there, we have all these different elements. And what we're going to do is we're going to set these up so they will feed into themselves. Okay, we're going to do self dot fur equals fur. Okay, self dot limbs equal limbs. Okay, so what this is doing is it's taking the information from when we're going to make this. So we're going to make a monkey here in just a second, and I'll show you how these fill in. Okay, so let's just get these working. Not exactly sure what we're going to do with live birth, but we have it here. And okay, so milk equals, okay. So effectively, we have a parent class called mammal, and it has all these attributes right here. Now, if we wanted to, we could also put in a definition function for something. Like we could change out live birth. Oops, I did that one wrong. We could change out live birth and make that into more of a function. Okay, so if we wanted to, live birth could be something like, let's see, we're going to have to take in some information from somewhere. Let's see, mating partner, maybe that's the one we have. But it can still take in information just like any old function. It can also just leave it out if you want to. Let's see here. And then we can say, just for instance, I'm gonna make this one into live birth right here. So I'm just gonna take this out. And I can show you how you can get these functions and use them. So we have live birth, and we're just gonna have it print something out whenever we call it. So we'll just say, you have a bouncing baby something, mammal. Okay, spelled correctly. Okay, so we have our function, we have our constructor that's giving all the elements that we're going to give to everybody else. And now if we want to make an instance of this class, so we're going to make a monkey. Make a monkey like this. We're going to say the monkey equals mammal. There's mammal. And then if we want to use this, we can just set it up like this. So we need to, whenever we're going to have an instance of this, let's see here, to fix that. There we go. If we're going to have an instance of this, we have to feed it what values are going to be there. So for fur, that's going to be our first one right there, fur. Let's just give it a string name. So we'll just say brown. Okay. And then for limbs, we're going to give it we're going to say 5 actually, because I think we can consider that prehensile tail to be an extra limb since it can grab things and hold it up. We're going to call that a limb. And then for milk, we're going to say monkey because it's monkey milk. All right. And these will be useful for us because now we have all this information about it. If we want to print out anything about our monkey, we can do print, and do a formatted string here, want that message to go away. Go away. I need to set that up so it go away. We're going to say the monkeys. Oops, okay, so if I want to have a quote in there, I'm going to have to do double quotes here. The monkey's fur is, we're going to be able to access that information like this. It's going to be monkey dot, and now we can see all the different elements for that class. So we have fur, limbs, milk. Now we're not going to see live birth here necessarily because we haven't really used it. We haven't really done anything with it. So in this instance, I'm just going to say fur. Okay. And then if we want to, we can also call monkey dot, let's see here. Well, let's just do this one first, and then we'll come back to the other. So this should print out, this monkey's fur should print out brown. Okay, so let's see what happens. Okay, the monkey's fur is brown. Okay, so it can reach up there and grab those elements. So this is effectively a completely new instance of mammal called monkey. Same thing here, if we do tiger, we're going to set that up the same way. There's a mammal. And let's say its fur is striped. It has 4, because its tail is just there for balance. And then let's see, the milk it has, tiger, yeah. So now if we wanted to do anything with this, same thing, would we be able to pull this information here. Now, if we want to do, oh, I'm sorry, there is one thing I was missing. On this setup right here for the function inside of this, we also do need to have self inside of that. I might need to type the whole thing out again. It needs to be lined up. So it should be def, live birth, self. Okay, yeah, already does that for you. Okay, that's going to act a lot better. So from tiger, we can go ahead and call that if we want to, live birth. But I need to do it with the same kind of dot notation that we used for like monkey fur. So we do tiger dot. Now it gives us all these options, and there's live birth. Okay, so now we can use all the functionality from that same parent class. And I'm going to go ahead and hit play. So you have a bouncing baby mammal, and the monkey's fur is brown. So you're starting to see how this information can get into a lot of different places. Okay, now from here, this is really all you need to do. As far as inheritance is concerned, we're inheriting these elements down into these new classes. Okay. If I wanted to, what I can do is make a whole child subclass that has its own functionality. Okay. But I'm going to save that for another time so we don't get too confused with what's going on. Because what you're going to be doing today is really just this. You're going to be making new classes. You will, actually, yeah, I think I did have it where you guys were making some functions inside those. So let me show you how to do that too. So we have class mammal, and this is how you can make a child class that's going to work with it. So we have a class here. This is going to be a subclass of the other that we're going to be using. So in this case, we're going to make monkey here. Well, actually, we have monkey and tiger. Let's think, what's another one? Giraffe. Okay, so we're going to make a giraffe here. It's a class, so we want to make sure that the setup here is going to be capitalized. The colon there. We're going to initialize it. Actually, we don't really need a lot of other stuff in there. We just need to say which parent class it's going to be pulling from. It's going to be pulling from mammal. Okay, there we go. And since it's pulling from mammal, it's going to be getting all of this information anyway. We don't really have to worry about adding in all this extra stuff again. But what we want to have instead is the functionality that the giraffe has. So the giraffe feeds from the top of the trees. Okay, so we're going to say a special function for giraffe called long neck. Excuse me, long neck. And long neck is also going to need to have, whoop, self is in there already. That's handy. And what long neck is going to do is, in this case, it could do function. It could do some functions. It could do a lot of different things that we need it to. Just for kind of purposes of us showing what we're working on, I'm just going to have it print something as we did before. Giraffe. Is very tall and eats leaves on the top of the trees. Okay, now we're still going to set this up in the exact same way if we're going to make a version of giraffe. Okay, so here we have a tiger, here we have monkey. We're going to call this one like, we'll just call it long neck. And we're going to use the giraffe class for this. So we're going to say giraffe. Okay. And then we're going to feed the information that it's supposed to have. So it has to have fur first. So we have spotted. And then it has limbs. We're going to say 4. Number. And it has milk. It's crazy, but it does. So we're going to just say giraffe milk. Okay. Now, if we want to, we should be able to use long neck at this point. So I'm going to say long neck, okay, dot. And you'll see now we have fur, limbs, milk. We also have live birth because we pulled that from mammals. But then we also have long neck by itself. Okay, so now if we print this, we should get 3. Your monkey's fur is brown. You have a bouncing baby mammal, which came from our tiger. And now we have the giraffe. The giraffe is very tall and eats leaves from the top of the trees. Okay, so did you guys know that giraffes' tongues are blue because they get so much sun they have to worry about the melanin that comes into it, so that protects their tongue. So that's why if you ever feed giraffes at the zoo, you see that they have blue tongues. Very dark blue. All right, so this is the basic idea for a constructor. This is a constructor with that initialized statement right there. This is constructing all the pieces that you're going to need every time, right? So if I'm making lots of different versions, let's say I'm making characters for a video game, you guys have probably played enough video games to notice that there's one model and they recolor it over and over and over again. One of the best games that came out in a very long time, Breath of the Wild, the Legend of Zelda game, they have monsters that are the same monsters, but then they get recolored so that you can tell, like, oh, this one's a really tough one. He's silver. Oh, this one's not too bad. He's brown, you know? And they step up the difficulty based on the coloration. These are the same thing. This is the exact same thing. We're just making an instance, which let me run through these one more time. This is a class. This is a child class. This is a parent class. This right here, where we're making monkey and tiger and all these things, these are all called instances. Okay, so if I made monkey and then I made another monkey, so let's say instead I made one called capuchin. That's type monkey, right? And then if I want to make another one called a rhesus monkey, that's still going to pull from mammal. We're going to say its fur is gray. I don't know if a rhesus has. I think it has to have a tail, but I don't know if it's. I'm going to say 4 limbs on that one, and it has. I'm going to say it has monkey. Nope. Why not? Monet. Can't spell straight. Okay. It has monkey milk as well. So if what I wanted to do was print out, I want to print rhesus dot, let's say milk. Let's make it actually make sense here. And this monkey has All right, so what this is going to do, it's not going to print out anything other than, let's make sure it is different. That'll make sure that we get something different. It's just to show you that we have a different setup here. It's not defined. Oh, okay, what did I do? Name error, line 22. Here we go. Monkey.fur. Oh, okay. So in this instance, we changed the name from monkey. Capuchin. Gotta spell things right. All right, try it again. There we go. So this monkey has rhesus. That was horrible. No, that's what it's supposed to be. The monkey's fur is brown. Okay, we're sure about that. And all this information we're able to just pull from something that's already got the structure for us. We are building various mammals. These are monkeys, but we can show how they have different instances in them. If I change the information for rhesus, such as if I wanted to go in here and say rhesus dot milk equals elephant. Okay, now before it actually gets to the point where it shows the rhesus, it should actually change. This is how you're going to change things inside of the class, just like you do with a variable. We'll see that for some reason the rhesus monkey has elephant milk. Okay, so that's how you can change those things. All right, that's pretty much it on classes. Inheritance, as I said, is you getting all this information and being able to use it inside of specifically a child class. But if you're using it with instances, you're making several instances, like these are all the monkeys that we could keep making monkeys. We could keep putting a lot of different monkeys out there. And every instance is a new object, and it's going to inherit all of this information from its parent class. Okay, so that's inheritance. This is your constructor. This is your parent class. And classes are just another good way to model things that are out in the real world. Okay, so I've got about 15 minutes till the end of class. Do you have any questions about what I've gone over, or any questions about the assignment, or if we're good on the assignment, you guys feel like you just need to kind of dig into it, we could also just move into questions on converter if you want to. Okay. If you feel like you understand everything that's going on, you're not going to have any issues with this whatsoever. If you can just give me a thumbs up, and we're in good shape. And you guys can take off if you'd like. Okay, Camilla, Will, thank you very much. You guys are free to go if you'd like. If anybody else has questions or anything, okay. Daisy, thank you. See yours.
Thank you.
Thank you. Okay, Brianna, Zanetta, do you guys have any questions?
No, I don't have any questions.
Okay, Zanetta, if you feel good about what you're doing, you can get your assignment on time, then you're free to go.
Okay, thank you.
Okay, see you later. Okay, Brianna, do you have any questions about anything you need help with? Any help there, Brianna? Do you need anything at all? You're the last one in class still. Okay. Well, I can probably try one more time. Let me just message you and see if that'll help. There we go. Sitting up Brianna right now to see if she has any questions. I guess if we don't hear anything back, I'm going to go ahead and log off. Okay, well, I'm going to go ahead and kill the meeting then. If you have any other questions, just please get with me and we'll try and take care of it over email or something along those lines, okay? I'm going to go ahead and end the meeting. Hope you guys have a good one. We'll talk again soon.